we go, last section of the year. Isn't that exciting? So what we're going to do is we're going to solve for x, but we're going to have logarithms and all that kind of stuff. And there might be some things that don't, actually a bunch of these don't even have logarithms at first. When you first look at it, you're like, well, what's this got to do with logarithms? Well, it's going to look like an exponential, and so what are we going to do? We're going to take that exponential and we're going to change it into a logarithm. All right, so let's take a look at the first. So a lot of the stuff that we were doing about changing from one form to the other really comes into play here. Okay, that's why we learn how to do that stuff so that we could get to this point. I mean, just knowing how to change it from logarithmic form to exponential and back and forth really doesn't do you any good unless you actually solve for something, and that's what we're doing here. So let's do the first one. And again, there's several little I always want to say tricks, but we'll just say that, okay? There's certain little things you need to do, little tricks to this to solve for x. Now, if you look at this is a little different than stuff that we've solved for before. It's not like this. It's not like 7x equals 12. You know what to do with that. That's easy, isn't it? Divide both sides by 7, and there's your answer, 12 over 7. Well, that's not what this is. Look where the x is. This is a lot different. Where is the x in this situation? It's the exponent, right? So we're solving for an exponent, which I don't think we've ever done before, okay? So we're solving for an exponent, which is a little different. So what we have to do is we have to get that x out of the exponent. So we've learned some things lately on how to get that x out of the exponent, all right? Maybe with logarithms. Remember, if I had a logarithm out in front of this, what do you think I could do with this x? I could actually move it out front, and now it's not in the exponent anymore and all that, okay? But we don't have a logarithm here, do we? But we could make one, all right? So what we're going to do here is this. Remember the rule in algebra that says whatever you do to one side, you can do to the other side? The same thing holds true with logarithms, okay? What I can do is I can take, we're not like multiplying it by the log, but we can take the log of one side, and then we can take the log of the other side. Now, if I put a log and no base, what is that automatically going to be? It's going to be base 10. Remember that ln that you saw before? We haven't messed with that much, and I haven't talked about this too much, but the natural log is the same thing as log base what? Do you remember what the base is? It's e. And e is a number kind of like pi. You know how pi is 3.14159? It keeps on going and going and going. Well, e is the same type of thing. In fact, let me just show you real quick. This is that's what I'm going to show you real quick. So, yeah, what does E equal? Let's see. I want to find one where it takes it out a whole bunch of places. Well, let's go to Wikipedia. Let's see what they say. I know you're not supposed to believe it, but this is how you get E. All right, if you wondered how you get E, there's a formula for it. It's 1 plus, now look what they do. They it's a pattern, it's a series is what they call it, the sum of an infinite series. Infinite because it keeps on going, it's a sum because they're all being added together, and it's a series because you kind of apply the same pattern over and over again. You start with 1, and then it's 1 over 1, and then look, there's still 1s on top of this whole thing, so they're all inverses. But look what you do to the denominator. You take this first one, you multiply by 2, then you multiply by 3, then by 4, then what would this be? That times 5, it's 1 over. If you add those all up, and you keep on adding forever and ever and ever and ever and ever, okay, it's going to be, now if you look at this is a 1, isn't it? Plus 1, which is what? 2. 1 plus 1, right? Okay, 1 plus 1. So what'd you learn today, kids? Well, I learned 1 plus 1. Right, there you go. So how's that for your last week of senior math? 1 plus 1 is 2. But what's this going to be? 1 over what? 2, which is, it's a half, isn't it? And this is 1 over what? 6. And this gets smaller and smaller and smaller and smaller, doesn't it? Okay, so if I go out 100 places, that 100th place is going to be very, very, very tiny. So, but if I would add up all those numbers, you would actually come out with about 2.8 and a little bit more. I'm trying to think. I'll tell you what. It's called Euler's number or constant. Euler's number. It looks like Euler's, but they pronounce it Euler. Okay. Oh, it still gives you that same thing. Euler's number. Let's see. Let's go to this one. Ah, there it is. And more. I had one. Shoot. So it's an irrational number. There it is, 2.7. Did I say 2.8? I meant 2.718. Usually we say 2.718. And you know how people memorize pi, 3.14? They usually just stop right there. Well, Euler's number is kind of the same deal, but they usually say 2.18 or 2.718. Now, if you put it in your calculator, it kind of looks like it repeats the pattern, which an irrational number does not do. But if you look at this, see, it doesn't really repeat that pattern. It kind of looks like it does, doesn't it? There's an 8, there's a 2, there's an 8, but then it starts changing. All right, and it gets real crazy. And it keeps on going forever and ever. That's why they say and more. All right? Does that make sense to you? All right, so that's Euler's number. So that's what E is. So if you had, what is this? It's log base, what? 2.718, okay? And then that's ln. And then if you have just log base 10, that's just the log. Now, with this rule that I'm going to show you right here, you could actually take the natural log of both sides, or you could take the common log of both sides. This is the natural log. This is the common log. It doesn't really matter which one you pick. If you probably don't have your book in front of you, but the book actually uses the natural log, but it doesn't make any difference at all. You could use either one. All right. So how does this help us? Well, it helps us because we have a lot of rules with logarithms now. We learn a whole bunch of rules with logarithms. So what we're going to do is we're going to apply some of those rules. So watch what we're going to do. We're going to take this x, and I'm going to chuck it over here. That's called the power rule. Remember that rule? If it's up here, you put it in front. All right. So now let's see what we get. We get x log 7. Remember, this is a common log, so this is the kind of log you can just put into your calculator. All right. So if it just says log 12, you put that into your calculator. So watch what we have here. What are we trying to solve for? We're trying to solve for x, aren't we? So how would I solve for x? Remember what I did earlier when I said 7x equals 12? How did I get x by itself if it's being multiplied by a number? Just divide. Well, look at this log 7. This is just a number that you're going to put in your calculator, isn't it? You're going to hit 7, hit log, and get a decimal, aren't you? That's what the log of 7 is. So you saw it. Tell me. That's right. Divide both sides by log 7. So watch. Log 7, and that's log 7. All right, so that cancels, and look what you have. You have this right here, log of 12 over log of 7. Throw it in your calculator, and you get a number, which is 1.2770.
Didn't you say 1?
I sure did. I can't remember what I said. 1.2770. Forgot the 1. All right, it's approximately, I don't care if you put equals, but technically it is approximately because it keeps on going forever. That's what that answer is. So if you look at it, watch. 7 to the what? Around 1.277. 7 to that power should equal approximately 12. Right? Does that make sense to you? Let's see if that actually works. 7 to the, we use that little thing right there, 1.277. Let's see. Yep, it's pretty close, isn't it? Now remember, this isn't exactly 1.277, right? It keeps on going a lot more, so that's why this isn't exactly 12. But you get the idea, it's pretty close, isn't it? All right, so we just solved for 7. There's another way you could have done this. You didn't even have to do that log of both sides. You could have just taken this original problem. Let's rewrite it again. You could have taken that original problem. What was it? 7 to the x equals 12. You could have just taken this right there and just changed it to logarithmic form, couldn't you? So let's change this to logarithmic form. It's good practice on both of those things that we've learned, but you can do it either way, which is kind of cool. Watch. This is, so what do we say? Log base what? 7 of 12 equals what? X. Do you know how to do this right here? Change of base theorem, right? So what is the change of base theorem? We just did a whole worksheet on it. Right, log 12 over log 7. Does that look familiar? It's exactly what we put in, right? Right here, log 12 over log 7. Isn't that interesting? What do you think? It's pretty cool. You could do that one either way, couldn't you? But what that does, you already know that you can change that to logarithmic form. That just kind of verifies a little bit. It's not really a proof, but it does verify that, sure, we can take the log of both sides and we're fine, because we'll get the same answer by doing this as we did changing it to logarithmic form. You with me? Everybody awake? It's cold enough, right? You should be awake. It'd be hard to sleep in this. It is a little freezing. I like this. I like this much better than the muggy when you first walked in. I hated that. I hate that feeling that just swarms around you.
Most days I prefer hot to cold. I prefer cold to hot, hot, hot.
Yeah. Kicked off. Arturo, is it where you live? I know it's real hot all year long, but is it real muggy? Is it real humid? It's just like dry. Yeah, so like 100 degrees there is not like 100 here. Like 100 here is just horrible because it just feels like you're in a sauna. But in Mexico, it's not quite as bad. It's still hot though.
That in Mexico uses a.
Do you have air conditioning in all your buildings and stuff?
Different temperature scale.
Yeah.
They use Celsius.
Yeah, but it's hot though. Doesn't matter what the meter says. It's hot's hot, right?
I'm pretty sure.
All right, let's do this one.
It's 100 degrees Celsius.
Well, I know. I'm saying Fahrenheit. He understands. I'm talking Fahrenheit. So Arturo, do you have like air conditioning in all the buildings? Like, are the schools all air conditioned and stuff like that? Okay, because I didn't know because there's some places where since it's not humid, they don't have air conditioning. They just open the windows and you don't have air in your house. Yeah, that's what I thought. And he lives. Yeah, because the humidity's not that bad, so you get nice breezes go through and stuff. Good. All right, what about this one? What do you think you can do here? I got exponents on both ends, don't I? So changing this to logarithmic form is not really going to help us out. Okay, like it did, like I showed you on that other one. So let's go to that rule that we just learned today. So what do you think I'm going to do to both sides? Take the log of both sides, right? Take the log of both sides. Now, you could take the common log or you could take the natural log. It really doesn't make any difference. Let's just stick with the common log. It just looks a little nicer, I guess. I don't know. So let's do that. Let's take the log of both sides. So the log of this, right, equals the log of that. It's an x. Okay, so we did that. Took the log of both sides. How does that help us? Why in the world did we want to do that? It looks more complicated now than it did when I first started. Why in the world would I want to do that? Well, because I got rules that I could apply to the logarithms. Watch, I can take this and do what to it since I got a log out in front? Yeah, I can chuck that out in front right here, can't I? I couldn't do that up here. I had no rule that takes an exponent and just sticks it out in front of the number. But if I have a logarithm out in front of it, yeah, I can put that right out in front. Everybody writing this down? If you guys are not writing, many of you are. But if you are not, you really should write this stuff down. It's your last week. Come on, this is not the week to just cruise, all right? This is the week to put it into overdrive, all right, and to work harder than you've ever worked before for many of you. So let's do this. So everybody's taking the test on Thursday, no matter if you had an 88 or not. So make sure you know how to do this. So we stick this out in front. So what do we get? We get 2x minus 1. Now I'm going to be careful with this 2x minus 1. Since it's a sum, I'm going to put it in parentheses, okay? Then it's just log 3 equals, going to do the same thing here. This is x plus 2, so I'll put that in parentheses since it's a sum, and I'll put log of 0.4. Now again, what are we trying to solve for? Trying to solve for x, aren't we? Trying to solve for x. A couple ways you could do this, I guess. I'm going to do it, I think would be the best way. I'm going to take this log 3, and I'm going to actually, remember, it's just a number, okay? Pretend it's just a regular old number. What would I do with a regular old number if I had it being multiplied by this parentheses? I would distribute, wouldn't I? Okay? Now, it's going to look a little ugly, but it doesn't mean it's any more difficult, okay? I promise you, it's really not. It does look a little ugly, but let's just bear with me on this. So I'm going to take this log 3, which is just a number, all right? Let me just prove to you. Watch. Log 3. So log 3. That's just a number. 0.477 whatever. Alright? It's just a number. So I'm going to take that. Now I'm not going to make it 0.477 right here. Don't do that. Alright? Make sure you don't do that. Distribute the log 3 through both of these. So it's going to go through both of those. And guess what I'm going to do with the log 0.4? I'm going to distribute that as well through this. Alright? So let's do that. What's this going to be? Well, we always put the number out in front of the log. It just looks a little bit nicer that way. So I go 2x log 3 minus what? 1 log 3, right? Equals, let's distribute this. This is going to be x log 0.4 plus 2 log 0.4. Now, it's a little bit of writing, but it really wasn't hard. Did we really even have to do any arithmetic at all? No, I didn't have to do any multiplication. All I did was stick that 2x in front of the log 3, stuck the 1 in front of the log 3. That's all I did. I really didn't do any multiplication there. Now, again, what are we trying to solve for? I'm trying to solve for x. So what I'm going to do is I'm going to circle this x, and I'm going to circle this x. And so what do I need in algebra? I need to get the x, not on both sides, but what? Just on one side by itself, okay? On one side. So what I'm going to do is this. I am going to take this whole thing. I'm going to take this whole thing, and it's being added. So, Leslie, I'm going to subtract it from both sides. Look at this thing right here. This is just a number, isn't it? Log 3 minus log 3. What can I do what can I do to that? Take this and add it to both sides. Everybody see that? So that's what I'm going to do. So I'm going to subtract this from both sides. Now watch what I'm going to do. You know how in Algebra 1 you put minus x log 0.4? I'm not going to do all that mess. It just gets in the way. It gets a little ugly. I know it's going to go away, don't I? So I'm just going to mark it out. Now over here, I have to subtract it, don't I? This is already over here, so I'm just going to rewrite that. Okay, and then I'm going to put what? Minus x log of 0.4. See what I did? I just took this, subtracted it from both sides. So I subtracted it from this. You can't really combine them because they're not like terms. I just put them next to each other. Now, what's the other thing I wanted to do? I wanted to take this, chuck that to the other side, to the right side. And how do I do that? I add it to both sides. It really, if you look at this, it's basic Algebra 1. It just looks a little uglier because you got that log stuff in there. But technically, it's basic Algebra 1 principles. This is already over here on the right. I'm going to add it and put it over here. So I put plus log 3. We're getting there. We're not quite there yet. I still have two x's, don't I? I'll circle them again. I got an x here and an x here. But at least they're on the same side now. We've done this plenty of times before. What do we do with that x to only have one x and not have two of them? Find a common. Well, it's not a denominator. There's no denominators here. It's a common factor, right? Greatest common factor, remember that? So is there anything in common with both of these? Absolutely. The x is in common with both of them. So watch what I'm going to do. Again, this is an Algebra 1 principle when we've actually done this kind of stuff earlier in the year with some other type of problems. So what we do is we factor out the greatest common factor. Remember, we had a whole entire test and chapter on factoring, okay? So we factored out a whole, or not a whole, but a greatest common factor, which is an x. What's left over if I factor that out of this? What if I take this x out of this thing right here? 2 log 3 minus, if I take the x out of this, log of 0.4. Yep, it's 0.4. And then I'm just going to rewrite all this stuff because I didn't mess with this side at all. So all I'm doing is just bringing all this stuff down. One more step and you're actually done before you have to put it in a calculator. Now you have 1x by itself. Okay. Remember, first we had x in the exponent, which we didn't like. So we put log in front of it, moved it out front. Okay. But then you had to distribute. Then you got x's on different sides. You had to get them on the same side. So we got them on the same side. And now I had to get just one x instead of two of those x's, so I factored out a common x. And now what am I going to do to get rid of all this stuff right here? Divide, right, because it's being multiplied by x, isn't it? That's why I put it in parentheses, because you factored out the x. All this stuff is being multiplied by this x. How do you get rid of something that's being multiplied? You divide. So, again, I'm not going to put over all this stuff. I know it's going to cancel out, but what am I going to do to the other side as well? I'm going to divide by all this. So it's 2 log 3 minus log of 0.4. So that canceled out right there. So that's what x is equal to. But you got to chuck that into a calculator, don't you? All right. Sometimes this is the hardest part of doing this problem, is putting that into a calculator. Watch what I'm going to do, though. I'm going to put parentheses around this for my calculator, just for the calculator's sake. Watch. I'm going to put a parentheses around these two. then I'm going to put a parentheses around this. Now, if you wanted to, you could do this. You could just put all this in a calculator and write down whatever that answer is, couldn't you? And then over, put that into a calculator, write that answer down. But to me, that's more work than I really want to do. I'd like to do this all in one shot. Excuse me. All right, so let's do this. I'm going to put a parentheses right here. That's why I put a parentheses there. And I'm going to go 2 log 0.4. 2 log. Now, you're going to have to practice this on your own, okay? If you have a different calculator especially, you're really going to have to practice this. Plus log 3. Log 3. All right, I close that parentheses around the 3, but I also have to put that parentheses in there, so I'm going to put 2 parentheses. Does that make sense? All right, because that parentheses right there just separated that 3. Then I got to put that other one. Now what do I put? Divided by, put another parentheses. 2 log 3, 2 log 3, close that little parentheses, minus log of 0.4. Close that parentheses around the 0.4. Excuse me. And then put another parentheses to close that. Now, what do? I've already got the division in there, right there. So there's the top, there's the bottom, there's my divide. I hit enter, and bang, that should be the answer. Let's see what the book says. Yep, that's exactly it. It says round it to 4 places, 2, 3, 5, 7. So it's negative 0.2357. And that is your answer. Now, that took a little bit of work, okay? That was a little bit harder than the first one we did. But it's on the computer. It's online. So go through it. There it is. It's the purple and green one, okay? You need to go through it again. Remember, this is your last week for the seniors, and you got to make sure that you work hard, don't quit, don't put yourself on cruise control, even if you don't have to take the final. You're still going to take one more test in here, all right? And, you know, it'll be significant to your grades, so make sure that you're ready for it. And this stuff will be on the test. All right, so go over it again. Let me give you a worksheet, and then that'll be it.